Advanced Financial Modeling, Topic 4, Multi-Period Portfolio Models, Learning Objective number 3. We're going to create an Excel deterministic portfolio model with multiple periods. So here's the model. Let's go to the spreadsheet and build it. So in the spreadsheet, we have the assumptions are listed here. And that is the current income of the client is $65,000. They're saving 10% of their income. Inflation's 2.5%. Their salary will grow at 2.5% per year. They're currently 25 years old, have zero saved, want to retire at age 65, and in retirement are going to replace 65% of their income using their portfolio. So they're going to live on 65% of their, well, they're going to have to replace 65% of their ending salary with their portfolio. The other coming from other sources we'll talk about later. Here are some market assumptions. Here's a correlation matrix. Here's a covariance matrix. Here are the portfolio means, the asset means for stocks, bonds, and cash, and volatilities for stocks, bonds, and cash. And I've already calculated the person's salary, age is $65,000 today. And then it's going to grow at 2.5%. And here you can see I've hidden some rows. You can unhide them by selecting the area and right-click unhide. But you can see at age 65, they're expected to make $174,000 per year, assuming they grow at 2.5% a year. And I also have created a asset allocation rule. So this is a common rule in financial planning, and that is personal financial planning, and that is put 120 minus your age in stocks and the rest in bonds and cash. So if you are 25 years old today, take 120 minus 25, that's 95, and put 95% in stock. And then I just made a simple rule that the other 5% is split between bonds and cash. So notice at age 30, 120 minus age 30 is 90, so 90% stock and 5 and 5 in bonds and cash. And age 50, 120 minus 50, you're 70%. So, and this continues up until the person is either dead or 100 years old. 120 minus 100 is 20% in stock. So this is a common rule that some people will use to talk about a reasonable asset allocation for the rest of your life. The idea is when you're young, you're starting out in lots of stock, and when you're older, you are less tolerant of risk, and so you're going to reduce your exposure to that. Another justification for having a lot more stock when you're younger is a couple things. One is maybe stock returns are mean reverting. So if they crash, you'll have 40 years to make up the money. Also, when you're young, you can take a lot of risk with your portfolio because your biggest source of wealth is probably your human capital, the present value of all your expected salaries over your life. So you can take more risk with that portfolio. So these are my asset allocations. So I'm going to start off at age 25 with 95% in stock, 2.5% in bonds and cash. Here's the portfolio mean. Notice I did an M-mult, the asset allocation percents, the W's, and multiplied that times the mean returns. And since I could use an M-mult here, by the way, because it's a row times a column, and you're allowed to do a row times a column for the inner dimensions to be the same. And so that's my portfolio mean. And then my portfolio vol. Notice I normally, in prior lectures, use the formula M-mult transpose W SW to the 1/2 power. Now, this is slightly different than that because that formula I gave you in prior topics assumes that weights are in columns. These weights are in rows. So notice I had to switch the order of the transpose. It was normally up front. I switched it because for the matrix algebra to work, I had to make a few adjustments if the weights are in rows and not columns. So this is actually M-mult, WS transpose W. Okay. Here's my year-end contributions. I'm making $65,000. I'm going to contribute 10%, so I'll anchor that 10%. Oh, something weird in that cell. Let's try that again. My $65,000 times 10%. Anchor that, and there we go. All right, looks like that has a weird cell name there. That's okay. All right, so these are my salaries. I can copy that down if I want. Actually, I can copy all these three down if I want. All right, so you can see the portfolio mean is going down over time. Portfolio vol is going down over time as we move out of equities. And I can copy that down even further if I want. Okay, so there we go. Notice, well, let's do our portfolio. Okay, so we said our contributions are going up with our salaries. And let's do our end of year portfolio balances. I'm assuming that these are end of year contributions. So let's do this formula. My portfolio balance times 1 plus the mean plus my contribution. Okay, there's my $6,500. So my at beginning of the year, I started the year with $0. At the end of the year, I contributed $6,500, and I can now copy this down. And what you see is I'm expected to have $1.69 million at age 65. Okay, so this plan is expected to have a value of $1.69 million. But let's see what happens at the year of retirement. So we'll assume that this is the last year you're working, age 65. At age 66, you no longer have an income, and you're going to withdraw 65% of your portfolio balance. I'm sorry, you're going to draw 65% of your final year's salary from your portfolio. So notice it's just 65% of my $174,000. Then that's in theory, that's how much I need to live on to have this similar kind of consumption pattern throughout my life. But then I have that withdrawal amount, $113,000. I'm going to have that grow with inflation. So I can now copy this down. So for 40 years, I'm contributing. I wind up with $1.69 million. Then in my first year, I withdraw $113,000 out of the portfolio at the beginning of the year. And then I have that withdrawal amount grow to keep up with inflation. So I can now just copy this formula down. And looks like I'm assuming year-end withdrawals. That's okay. And so you see that the portfolio looks like it's going to last till about somewhere between 85 and 90 years old. So this is we call it a deterministic portfolio roll forward. The word deterministic means there's no probability here. All right, it pretends as if everything is with certainty. It means that the asset returns are giving you this given return. So this is our portfolio model. Let's talk a little bit about some of the results of this model. And I want to talk about three key metrics in financial planning. Number one is the wealth to income ratio. So at age 65, how much have you saved in your portfolio? We'll call that wealth. And what was your final year's income? All right, so research suggests that you're going to need probably 5 to 15 times your final year's income if you retire at the age of 60, 65. Um, more if you're richer, because you're going to need to replace more of your income, and probably less if you have a lower income, mostly because Social Security is going to replace much of your income. So that's the first one. The income replacement ratio is the other one that's really important, and that is in retirement, how much of your income do you need to replace using your private portfolio savings or retirement savings to preserve kind of your consumption throughout your life. In other words, when you retire, you don't want to reduce the quality of your life. You want to kind of have consumption to be relatively constant. So in this model, we assumed that this person needed to replace 65% of their retirement income. So let's take a look at that assumption. So they were making 174. You can see that in their final year. We're making 174. And then they withdraw $113,000, which is 65%. That was my income replacement assumption. Now, why shouldn't it be 100%? Why don't I withdraw 174 to maintain my current living standard? A couple reasons, and I'll go back to the PowerPoint to talk about those. A couple reasons are, one, you are no longer saving. So if you've been saving 10% of your income all of your life, you've always been living on 90% of your income. So for that reason alone, you would only need an income replacement rate of 90% to have the same consumption. Another reason you don't need to replace a high percentage or 100% of your income with your portfolio is often taxes are lower in retirement. One is you have lower income and with the marginal tax rates. And the other one is just things like Social Security. You no longer pay Social Security tax or Social Security contributions, those payroll taxes, and Medicare. And the last reason is you will get, most likely, some kind of Social Security benefit. So for the low-income people, Social Security can replace as much as 50% or more of their retirement. Of their portfolio income. So for that reason alone, for those three reasons, I chose 65% income replacement ratios. Now, let's talk about some of the disadvantages of the deterministic model. One is volatility was not in the model. There's nowhere the standard deviation had an effect. So it could not answer questions like, well, what's the probability that those returns, which I assume do not work out, and I don't have enough money to retire. So what we need to do is move on to a stochastic or probabilistic model in the next section where I can answer those types of what-if scenarios.